Yeah, so for week 8, week 9, and week 10, that's the time for you to presenting your book reading and your abstract. So here I have received some feedback about the sign up time of presentation. So I have got 24. You can try to find your name here. If you don't find that, please tell me, and I can sign up for your time. Yeah, you can find the link to this Google Sheet on the announcement I sent last week. And here we have a popular science book presentation. So this is for those who cannot attend the lab, attend the presentation in person. If you are presenting in person, actually you don't need to use this link. But if you want to upload your slides, you can also upload here. But if you are not presenting in person, you need to use this link to upload either your slides with your recorded presentation or your slides along with your write-up essay for your presentation. We have some tips for your presentation because the time limit for each person is 8 minutes. So usually the regular pace for presenting is one page of slides each minute. So the regular length is 8 pages of slides. You can adjust the length a little depending on the pace you're speaking. And do not simply write the paragraphs of text on the slides because it's very tiring for audience to read the text, especially a very long text from the slides. So I would suggest you to have more pictures related to what you are talking about and put some key points, some bullet points along with your picture. The major information should comes from your talking, from your speaking. And remember, you need to also put your the information from your abstracts to your presentation slides. You need to talk about that a little and describe how it's connect, how it contributes to the theme of your book. Yeah, and do not simply reading your slides. Yeah, if you have pictures, you need to talk about your pictures. So today's topics are sedimentary rocks, like similar to the previous labs. Today we have 10 samples of sedimentary rocks. Sample 1 to sample 10. So 10 of today's lab assignments, they are identify these sedimentary rocks. So this assignment, the question number is very, it's not as many as previous one. We have 12 questions in total. So 10 of these questions are identifying the sedimentary rocks. And the other 2, you need to use that AR sandbox to work on the questions. So what is sedimentary rocks? They are the rocks formed by the accumulation or deposition of minerals. And sometimes it contains the organic particles. It's formed usually at Earth's surface. The forming process can be divided into 3 steps. The first one, the pre-existing rock, the original rock, is eroded or weathered by the external forces. So this pre-existing rock can be either igneous rock or sedimentary rock or metamorphic rock. Yeah, these rocks are eroded, weathered by external forces like the water flow or the wind flow. And their fragments, the pieces are transported by the winds, by the water, and they deposited again into layers and finally. And then these layers become compact and cemented together and formed the new sedimentary rock. According to the eroding and formation process, we can further divide them into two groups, the clastic and the biochemical sedimentary rocks. For the first one, plastic, the pre-existing rock, they are physically destroyed by the water or by the wind or by other liquids. They are physically destroyed, and the fragment is carried by these things, but finally they settle down and form the new sedimentary rock. For the biochemical rock, the pre-existing rock is dissolved or other ways of chemically destroyed by the water or other liquids. And this dissolved components finally precipitated again and formed the new sedimentary rock. For this kind of biochemical rock, sometimes they can have organically created debris inside, like the fossils or the broken organic shells. Sometimes you can see them inside the biochemical sedimentary rocks. More details about plastic sedimentary rocks. So rocks, they are composed of plastic sediments like the grains, matrix, and the cements. This cement is not man-made cements. They are natural things that glue these things together. They can be broadly divided by largest common grain size. As this table A shows, we can divide them by the grain size. If the grain size is very large, it belongs to the first type. And when you're going down, the grain size decrease. Finally, they become very, very small. And you can almost not see individual grains in the rock. We can also cluster them according to the angle of the grain. If the grain has very sharp angle, we call it angular. If it's not so sharp, we call it sub-rounded. And then we also have very well-rounded that does not have any angle inside. We can also classify them according to the sorting extent, whether they are poorly sorted or well sorted. And this table D is to show you the grain and the matrix in the sedimentary rock. What is grain and what is matrix? The grain size in plastic rock can also reflect the environment energy, like how high or how low the energy is in the environment. Because for different grain size, it needs different energy to carry that. If the grain size is very large, then it needs high energy environment to carry that. You need like the rivers, the glaciers to carry the grain and form this kind of sedimentary rock. For the median, if the grain size is median, then the energy is also median. If the grain size is very small, then the energy is also very small. Very small, like the low energy environments, for example, the deep marine or the lake environment, where the water flow is almost silent in this environment. The biochemical sedimentary rock is formed from precipitation. It's typically formed in the intertidal zones. Here, the intertidal zones means the zone above the sea level of the lowest tidal, but below the sea level of highest tidal. So at these intertidal zones, we have some water left. When it exposed to like the sunshine, the sunlight, the water part will evaporate, and we have the solid part left. It's precipitated, and then this solid part formed the biochemical sedimentary rock. Sometimes it can be crystalline. The hardness will be similar to that of the composing mineral. So in today's example, we have two this kind of crystalline. The first one is the rock gypsum, and the other one is the rock salt. So the rock gypsum and the rock salt, you can just feel them as the simple cluster, simple assemblage of the mineral gypsum or the mineral halite. So their appearance and the hardness is very similar to the minerals. Oh, this is gypsum, this is salt. Okay. And in this kind of rock, sometimes you can see organic debris inside. For example, sometimes you can see fossils inside, or the broken organic shells inside. For this kind of rock, we call them the fossiliferous limestone. If you can find fossil inside, it's the fossiliferous limestone. Sometimes it's formed in like the environment, the condition, lack of oxygen, then it becomes the coal, which is a very important energy source of our daily life. So today, in total, we have 10 sedimentary rocks. The upper table, we have 4. The lower table, we have 6. So I will teach you how to identify them. You should first observe the texture, the appearance of the rock. If this rock looks like the halite, or it looks like the gypsum, then we call it the rock salt or the rock gypsum, depending on the component. If its appearance look like the quartz, like a glass, then it's actually the chert. If the fossil, sorry, not fossil. If the rock, the appearance is white, and if you scratch that by your fingernail, and you can see some white powders left on your finger, this rock, we call it the chalk. Its component, its material is very similar to the chalk we write on the blackboard. If you can find the fossils inside, it's the fossiliferous limestone. If you find a rock with like this kind of chaotic appearance, chaotic texture, it's the coquina. This chaotic texture comes from the broken shells inside the sedimentary rock. And for above these 4, we distinguish them according to the grain size. If the grain size is very fine, it's very small, it's the sandstone. If the grain size is medium, it's the sandstone. For sandstone, you can easily see the grain like the sand inside this rock. If the grain size is very large, it's coarse, then it should belong to these 2. The difference between these 2 is the for this one, for the breccia, the grain has very sharp angle, so you can see very sharp angle inside this rock, inside the breccia. But for conglomerates, for the first one, the grain size is also large, but the angle disappears, so it's almost rounded grain inside. The above is for the sedimentary rock. we have two questions about the AR sandbox guideline. So this sandbox is used to show you the different landscapes. And you can mimic the rainfall in the sandbox. You can see many black lines on the top of the sandbox. They are topographic maps. Remember, use that before you use that, you need to clean your hands. And I would suggest you to like form 3 to 5 people group and come to this sandbox to operate that and answer the question. For the projector above, don't touch that. And if you need any help or you need to change the fluids inside the sandbox, please let me know. For those who attend remotely, we have a remote option for those cannot attend the in-person class. So on by Google Earth, you can also finish the first 2 questions. Here is an important concept in the water system. It's the watershed. So like look at this figure. You have a valley in between. And we have another valley here, another valley here. So this line, see this line, between 2 valleys, there is what we call divide. And all the waters inside the valley, we call it the watershed. So one of the questions is to identify the watershed and the divided, either in the sandbox or in the Google Earth. If you choose the Google Earth option, you need to find a topography has watershed and divided inside. So here is an example. This is like the Henness State Forest in North Canada. So you can see here we have a valley, a water valley. Here another valley. Here another valley, the river valley. So you see the line in between is what we call, this line is the divide. And here we have another divide here. And this is a watershed. This is another watershed. This is another watershed. Finally, they merge together into the ocean or to a lake. Yeah, so if you need any help about the sedimentary rock or the sandbox, just raise your hand and I will come to help you.